Hi, welcome to Chapter 12. Chapter 12 is when we get into dealing with text. How do we get text and how do we basically kind of manipulate it, and how do we go in and kind of look at things and dissect a string and split things apart. Maybe we want to take one string that's got first name and last name into it and split it out into first name and last name. We could use that space as kind of a separator. So that's basically what Chapter 12 is looking at. So now we're going to have to rely on a lot of functions, built-in functions, and not all the functions we're going to see are going to be available in Raptor, but we can kind of work through it. So here's some common string functions. We got length, we know we got that. Append, that means we can actually take two strings and glue them together. Two upper, two lower, we've seen that. We've got substring, we know how to do that as well. Contains, we can actually say, does this string contain these characters? Like maybe I'm looking for IE. Does this string contain an IE put together? String to integer, we can convert a string to an integer. String to a real, convert it to a real data type. And is integer, I can check to see, is it really an integer data type or is it a real data type? So character by character processes. Let's take a look at Raptor 12.1. And so here's what we've got. I've got name is Jacob, and we're going to put name 1, put name 2, name. So again, remember when we put the square brackets like that, think of it taking that string and converting it to an array. So we're just going to basically display each letter one at a time. So we're going to grab the letter in position 1, 2, 3, 4, and 5. Now, again, depending on the language you're using, it may start with 0 as opposed to a 1. So, but anyways, it's a very simple program. I run it, and it basically has JACOB. Okay, we've seen this before. Character by character, basically converts, it treats the string as an array, basically. Okay, so we continue on. So 12.2, so 12.2 shows how a loop can be used to step through the characters in the string. So before, we basically in 1 we basically knew we had that many different characters, so we did it that many times. So now we're going to basically do this. We got the name Jacob, we create our index, we've got a for loop, we say index, if the index is greater than the length of name, because remember length of is a built-in function, once that's true, we're going to basically drop out of this loop. If not, we're going to say put name index. We're going to add 1 to the index and come back around. So basically a for loop. So we're going to get the same exact results. Okay, and there's Jacob again. So this now will work with any name. We could put any name inside of that box, inside of this field right here of name, and this thing's going to work for any one of those. So 12.3 shows an example of changing individual characters in a string. So we're going to basically take a string and actually change some characters. So let's take a look at 12.3. So very first thing we do is we create a variable called str. We create our index. We get the sentence, so we get the string. We ask the user to type in something, and then we go through and we're going to do this until the index is greater than the length of the string. So if the index, if that character is equal to a t, we're going to basically then put string index, change it to a d. We're going to say that particular item is now equal to a d, and then we go through our loop again, and then we display the string all over again. Okay, so what do they want us to look at? That kitty cat. Okay, so I run it and say look at that kitty cat, and when I run it, it comes back and says look add THAT giddy cad Okay, so everywhere there was a T, it changed it to a D. Now, let's see how they, yeah, they did the same exact thing we did. We didn't use a change. So, character testing library functions. Again, I don't know how many of these we have in Raptor, but normally we have a built-in function that lets us see, is that a digit? Is it a letter? So a digit meaning a numeric value. Is it a letter? Is it a lower? Is it an upper? Is it a white space? Okay. Is it a space, or is it a dash, or is it something else? Okay. So let's take a look at 12.4. Again, I don't know how many of these are available to us, so I don't know how this program basically works here. So I got my str. Create that and then initialize it to a null value. Here's my index set to 1, upper set to false, uppercase count is set to 0, numeric value, and then we get a sentence, we get the string, and then we basically call is upper. So is upper is going to check to see, oh, how many, so basically we're checking to see how many letters are uppercase. Okay. And if they are uppercase, we're going to add 1 to count, and then basically go okay. So we're checking to see if the A string is equal to, so it says, again, this is one of those things that we have to kind of rely on somebody else who kind of wrote this particular application. So again, we're just going to pretend that is upper is a built-in function, basically. So we're looking at one of the characters, ASCII A is 65, and ASCII Z is the 90. So we're basically checking to see, is it between 65 and 90? If it's an ASCII, we're going to add 1 to the count, and then we're going to basically add 1 to position and go back around. Okay, so that's really all we're doing. So again, we have to kind of rely on that particular piece that was written for us. So we run it. And what did they want us to type in? Ms. Jones will arrive today. Okay, so Ms. Jones will arrive today! Exclamation point. Hit the enter key, and that string has 7 uppercase letters. Okay. Pretty cool. Again, these built-in functions are not built in per se, but they've been written for us, and we basically have to utilize them as at face value. So here's the end of Spotlight. Many password protected systems allow users to set up their own passwords. For increased security, systems usually require that passwords meet minimum specifications. So again, what we're going to say is the password must be at least 8 characters long. Password must have at least 1 uppercase, have at least 1 lowercase, and at least 1 numeric digit. So 12.5, let's see how complex this bad boy is going to be. So we had to create an upper count, a lower count, and a digit count. So we know upper and lower case count because we just saw what it did in the previous one. We got digit count. So here's what it does is, oh, we're just looking at position 48 through 57, which is a 0 through 9. Okay? So that's an ASCII 0 through 9. So we'll know if it's got a digit or not. So really what we do, we pass in the string. It goes through it character by character to check to see if that digit count is equal to 1. And when it comes back, we basically say if the password length is equals the minimum length, and the uppercase count is greater than or equal to 1, the lowercase count is greater than or equal to 1, and digit count is greater than or equal to 1. Okay. Now, normally we would have digit count. So, you know, this would probably work better if, this would work better this way. We are going to basically say, I'm going to create a new variable. I'm going to pause this for a sec. I'll be right back. Okay, so here's what I did. Instead of using a count, what I did is I'm now using a Boolean. So inside of each one of these, that instead of using this, I now created what's called is uppercase, and I set it to false. And if that string position is within that range, we're going to go ahead and set that to true. So now back here at the main, I'm checking to see if the password length is greater than or equal to the minimum length. And the minimum length up here is an 8, so that's our constant. And I'm checking to see is uppercase equal true, is lowercase equal true, and is digit equal true. If those are all three true, the password does not, if it's not true, if those are all not true, the password does not meet the requirements. Okay. Now, we should put something over here on the yes side, but normally this would basically, the user would type in a new password, and if it accepted it, it just goes on, and maybe goes on within the screen. So this might be a small piece of a main program. So let's run it and see what happens. So I'm just going to type everything all lowercase password. It's 8 characters long. What did I not do here? My bad. Hold on. Okay, I forgot to change some variables in some different spots. Okay, so now we're using Boolean instead of the count now. So I basically run this, and I type in password and hit it, and it says that password does not meet the requirements. Now, we could actually display more, like, hey, it doesn't contain an uppercase letter, it doesn't contain this, doesn't contain that. So, but we could, but we're not going to. So again, now let's try it with it's all valid. So uppercase password 1, and basically everything comes back fine. Okay. So basically what we're saying is, hey, if it's within that range for each character, set that to true. Okay. So here's another one. We got telephone numbers. So telephone numbers in the United States are commonly formatted to appear in the following manner: parentheses, digit, 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 right parentheses, and then digit, 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 dash, digit, 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 digit. Okay. So in number 6 here, program that works with telephone numbers usually to unformat numbers entered by the user. Okay. So let's take a look at number 6. And number 6, basically, we get a phone number. We set this variable valid, which is Boolean, to false. We have the enter telephone number. The entry number should be in the format left paren, digit, 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 boom, boom, so on and so forth. We get that phone number. Then we check to see, is it a valid format? So up here, we are in this valid format. We are passing in the phone number and the valid. Okay, so the valid is going to be set as, so the phone number is input, valid is output. So we set valid equals false. It should already be false coming in. And we got the length of the phone number. Is it equal to 13? And is the phone number 1 a left parenthesis, and the phone number at the 5 position, is it a right parenthesis? And is the phone number at the 9th position a dash? If all of those are true, we set valid equal true. Now the only thing we haven't done is gone in to make sure that they've typed in digits as opposed to letters or numbers. So we could basically go through and do that as well. Okay. So now main, we come in, if that's true, we're now going to unformat the number. So we come over here to unformat. So we type in the phone number. The phone number is coming in, it's going back. So we got a temp phone number set to empty braces, or empty, basically no value. We set our index equal to 1. We go in, once our index is greater than the length of the phone number, we're basically done. So we basically go in and say, if the phone number index is a left paren, or a right paren, or a dash, or a space, no, a null value or a dash, we don't do anything. If it's not, we're then going to then put the temp. We're going to basically say the temp number is equal to the temp number plus this digit. Okay, so we're basically we're going digit by digit by digit, and we're checking to see, is that digit a left paren, a right paren, or a space, or a dash? If it is, we're not going to do anything. If it isn't, we're going to move that digit over to temp, and we're going to keep adding it to the temp. So when we get done, we're now going to say the phone number is equal to the temp phone number, which overlays that phone number, and then when it comes back, we can then basically display what that unformatted number is. Okay, so let's first do this. Let's first do an invalid number. So I'm going to type a left paren, 555, a dash, 333333, bunch of threes, and click OK, and it comes back so that number is not properly formatted. So now let's put a properly formatted number in there. So left paren, 555, 111-2222. Okay, so I run it, and it comes back. The unformatted number is, notice it's basically got 555, 111-2222. Okay, so pretty cool stuff. Again, we're not really learning anything new because, again, the program should be relying on a bunch of built-in functions, but we had to write those functions ourselves, so not too bad. So here's 12.7. It says, now let's look at an algorithm that takes an unformatted number, which is a series of 10 characters, and then basically we're going to take an unformatted number and make it formatted, is what we're going to do. So here we have our phone number. We get that number. We then say phone number is equal to phone number plus a space. I don't know why we're doing that. And then we say phone number is equal to, say this is phone num plus space. Length of phone number, if it's less than or equal to 13, we're going to basically say that is not 10 digits. That's not 10 digits, and we're going to display that number is not 10 digits. And then so we call format numbers, come over here, and this is basically where we then put in a, if the index equals to 1, that means we're at the first character. Let's go ahead and make that a left paren. And we come down here and check, see if it's equal to a 4. We're going to put in the right paren. If it's equal to, and then we continue on. We still take each digit and add it to that temp number. So the very first thing we do is if it's a 1, we're going to add the left paren, and then we come down. We still add the number. We come back around. If it's position 4, we're going to add that, okay, so on and so forth. Now realize that once I add that 1, okay, I'm going to add another number, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, okay, or 7, I should say. Okay, so let's see how this works. I'm going to type in 555, 111, 2222, and let's see what happens. And it comes back, says that formatted number is left paren 555, right paren 1111 dash 2222. Pretty cool. Pretty cool stuff. Okay, so that's the end of chapter 12. Again, not a whole lot of new stuff, but just realize that a lot of the languages we're going to be using are going to have a lot of built-in functions, so that functionality is going to be built in, like is it a digit, is it numeric, is it a letter, is it this, is it that. So we'll have those built in for us. We had to write a lot of those, or I should say I did through a lot of research online, and I got those built in so you can actually copy and paste my procedures into your different programs in order to use those functions as though they were built-in functions. Okay, if you have any questions, make sure you give me a call. I'm glad to help you, and we'll see you next time.